2026 is a very unique year for us with geospatial AI. For the last decade, it's been about tools. We're seeing this transition to become more intelligent system. And for that, what we have is ArcGIS as a platform for geospatial AI. Before I go too further, I want to talk about our vision, our broad vision in this space. It's really a transformational one where everything that we build is well architected and it's well integrated, because that's fundamental to how AI gets infused in our GIS workflows. It's, of course, to drive innovation, and I think there's a larger ambition in being very transformative as we do this. And we slice it based on our own experience with AI and the emergence of new technologies. So we slice it across the science, the experience, and the overall impact of GIS in the work that we do, the work that you do to fulfill missions. And of course, a key aspect is the collaboration between people and machines as we do this. And in everything that we do, it's fundamental to how we do GIS itself, which is all about trust and control. It's about making sure that AI is not opaque in everything and being transparent and controllable AI too. If you look at why this combination of GIS and AI is powerful, it all starts with geospatial context, geospatial intelligence, and being able to derive insights from data at massive scales at high performance, doing analytics, real-time insights, automation, efficiency, and productivity. It's really about making GIS accessible at the end of the day. I wanted to pick on 6 specific examples to illustrate the point here, like automated data creation, data from satellite imagery or LiDAR, data conversions from various sorts, structured, unstructured data, analysis of various kinds, insights, being able to make more accurate predictions, and lastly, about productivity and efficiency that we are seeing with AI as a whole. Let's go a little deeper and try to demystify the technology stack itself, because not all things within the overall space of AI is the same in terms of its usefulness, maturity, and the applicability in GIS. We know that the ambition of AI in general is to mimic what humans can do from a perspective of intelligence. But within it, that's machine learning, and machine learning is a lot about how you can see patterns from data sets that are there. And at Esri, we've been doing that for more than a decade. Deep learning is a subset of machine learning where deep neural networks can do more advanced things, advanced understanding, and the foundation for things like generative AI. Based on the data sets that you see, you can create new kinds of data. And then there's supporting technologies like computer vision that know how to apply AI to, let's say, satellite imagery and images and so on, or natural language processing that makes it easier for us to be able to understand language, have a conversation, have a dialogue between a machine and a human. That's where large language models come in. And then there's also geospatial foundation models that we've been working on, embeddings, multimodal, and a key aspect of this, I would say, modern AI is about reasoning and planning and orchestration, setting some goals and knowing how to achieve those goals in a well-orchestrated manner. All of these are important coming together in frameworks. So GeoAI uses all of this, and most recently, we've seen the emergence of AI assistants and AI agents that we'll talk through today. And as we add AI everywhere, trust and responsibility are of paramount importance for us. We call this trusted AI in ArcGIS. Here's what that means. It falls into these 3 categories: that security and privacy is maintained at all times. There's ethics and fairness, which also includes like how fair these models work, and then being able to have the right transparency and control in everything that you do, because that's just fundamental to GIS. So it's always been about trust, your data, your processes, and your outcomes. It's no different between GIS and AI in GIS. To organize our efforts in product development as well as in the usability of our products, we've sliced this into 4 categories, and they kind of align into the advancements of AI itself. This is important to understand because where is AI useful and where it's maturing and experimental is good for you to know. Scientific AI, which is the alignment of Geo AI, the science of GIS and the expansion of it, is all about geographical understanding, spatial analytics, predictive analytics, and so on. And then there's assistive AI. And assistive AI is about having a conversation as assistants within applications, the human machine interaction. And then there's the emergence of agentic AI, which are like autonomous systems. They act and operate on behalf of the human when told to do so. And lastly, there's the backbone for all of this, a robust and secure infrastructure in the form of an AI framework that hosts these models that make sure that they are scalable. And it's pretty foundational to achieving these other 3 things. So when you align that to ArcGIS as a geospatial AI platform, here's how it falls out. There's Geo AI, and that includes our experiences within Pro and Notebooks and Deep Learning Studio as examples. And then there's the advancements of foundational models, geospatial foundation models and location embeddings. And we'll cover quite a bit of that tomorrow, like Sud was mentioning. And then there's AI assistants. These are assistants that are embedded into existing applications, so they're native in the way you use it, the way you're used to using these applications. And then there's these agents. They enable agentic, automated workflows. They're quite intelligent compared to the plain old automation that used to be there. And then, of course, you have the backbone of the framework itself. Of note is that for these agents to work, this backbone, this AI framework, exists within desktop, within web, and the server, because they're all 3 capable of hosting these agents, which are either ArcGIS agents or these custom agents. And then you have protocols like A2A, agent-to-agent communication, and MCP, Model Context Protocol, that enable interoperability between these systems. AI is not just for in your face and when you're completely aware. There's also AI that works behind the scenes. For example, to make search better, what you're looking for. There's semantic search that's powered by AI. And then there's item metadata, deficiencies in the workflows that we have. That's so fundamental. If you don't have good item metadata, downstream impact is pretty significant. Like these agents are not able to understand what this data represents, how it can be used. So we are using AI to promote the quality of the metadata that you might have. Here's something that Sud shared earlier. One thing I want to point out here is that in addition to advancing the science, the productivity, and the workflows, there's something foundational in what we're doing in trying to bring geospatial AI into ArcGIS. And that is reusing all your existing investments, your GIS assets, your data, your tools, your geoprocessing tools, your geoprocessing models, your GIS services, and all of that is happening within this framework. That's why I would say this is foundational enterprise geospatial technology that's becoming foundational in your enterprise AI workflows also. And as we do that, there are many advancements happening in each area, like we talked about earlier, being able to do each of these things. I want to highlight one area, which is building your business and mission-critical agents. In this area, there are various ways you can experience it. One is with agent-to-agent communication, being able to use our foundational geoprocessing skills and agents that ship with ArcGIS, as well as calling out and using external ones. And there are web components for building these agentic mapping applications. So as developers, you have access to these AI components. And we'll take a look at that in a couple of minutes. Let's start with AI assistants. It's really about streamlining your workflows, your work, and making it easier for you to use our existing applications. It's making them more accessible. And there are various kinds, like you see here, a variety of assistants, right from code generation to storytelling to survey creation to metadata creation, like at the right bottom that you see here, for helping you seed your metadata as you add new items into your portal. They're all powered by natural language. A prime example of this is the ArcGIS Pro Assistant. It's in beta, it's in private beta right now, so I'd encourage that you can join if you haven't already. It uses natural language to learn from your documentation. It uses natural language to create expressions, create queries, and it can also understand your intent and trigger actions within it. And there's, of course, more that you can keep expecting to see. The cool thing about this is, what is it for developers? If you're a .NET SDK developer, you're familiar with its capabilities. That SDK is expanded now to also allow you to extend the assistant itself. So you can register your domain-specific or org-specific workflows. You can capture your expertise, and you can introduce it into this as an extension to the assistant itself. Instead of just going on and explaining what it is, it's probably best to experience through a demo. For that, I'd like to introduce Ty Fitzpatrick. And Ty, take it over.
Thank you, Jay. In this demo, we're going to use ArcGIS Pro's SDK to leverage multiple AI assistant extensions to coordinate multiple actions for browsing data, performing spatial analysis, and summarizing results to help your users better understand their data. Let's take a look at recent weather events with this supply chain data set. So in my first query inside the Pro Assistant, we're going to look for all suppliers located in the greater New England area, including New York and New Jersey, and summarize the results inside the assistant. And this is using a graph query against the data and returning the results and having the large language model summarize the results in the pane. So here you can see each supplier, some of the properties listed, and so forth. Now, let's list their related parts and the total cost, and also calculate the estimated carry cost for 3 days. So for each of the suppliers, look for all the related parts in them, and the estimated carry cost is the total cost that it would incur for holding those parts for those 3 days while a storm passed. As well, it was summarized at the end. Now, let's list the average daily sales, summarizing each of the suppliers over 3 days and summarizing the total. So again, using a grounded in a graph query, we're querying the data, returning the results, and summarizing them for me to better understand them inside the assistant. Now, let's combine those queries and look for performance indicators for total inventory, average daily sales, carry cost, but also add a descriptive answer at the end of each one of the suppliers based on the data indicating the severity of the impact for that storm or risk that it might incur. So here's each of the suppliers and those properties. You also see at the end a reason or risk and a description based on the data. It also has this betweenness score, which is a data science indicator to indicate a supplier relative to other suppliers and a score given for its importance. And again, if you list down below, you'll see the total sales for all those properties, but also a nice narrative with Vertex Logistics being potentially one most at risk based on the data. Now, let's evaluate the weather impacts against the supply chain network in that area. So we're going to use the selection set of these suppliers and intersect them with the weather events, as well as the counties, query the data for both the supply chain network and those feature layers, combine the results, and aggregate them into the assistant. So you can see each of the suppliers, the state, the county, the population, the weather event, and the severity of that storm listed. As well, what's most at risk based on all those factors, and a summary at the end. And finally, we can summarize the whole conversation here. summarize the results of our conversation and analysis, providing a detailed assessment of what's most at risk or least at risk based on all the factors that we return from the data from those queries. So you can see here, the most at-risk supplier potentially is New York Industries with some of those properties, as well as the least risk supplier based on those properties and the storm impact, and finally, a conclusion at the end. So you can see how coordinating an AI assistant extension with multiple actions working together and then summarizing those results from the data into the assistant can help you better understand your queries. Now let's take a look at how I did that. So here in Visual Studio, I've got an AI assistant extension implemented. I've got a description for this particular extension describing what its intent is if the request comes in. I've got a list of rules based on all the different actions that I've developed and how they're coordinated and how they should behave together. Let's take a look at one a little bit closer, that spatial analysis one. So again, I have an AI assistant extension implemented. This allows me to evaluate my weather events. In the rules, it goes and gets the active map and also collects up all the map layers in there. So when I go and ask for the request and say, look at these selected suppliers, weather events, and counties, it can compare it with the layers in my map. And finally, I have my AI function for evaluating those weather events with the description, the input parameters here for the layers, for the input and target layers, and finally, the implementation of evaluating the weather events, where I go and I look at each of those suppliers and intersect them with the weather events and the counties. So using ArcGIS Pro and its SDK, we can create multiple AI assistant extensions coordinating multiple actions to help me browse my data, perform spatial analysis, and summarize my results inside of the AI assistant. Thank you.
Thank you, Ty. That was pretty amazing, the extensibility of the Pro Assistant. Next, we're going to expand to assistants that can help you generate code, like an expression assistant that's available within Arcade. Many of you know that Arcade, as an expression language, can do powerful things, and they're embedded into various applications within the workflows that make sense. We've enhanced it much further than it was doing before, and it's embedded into more applications. And the key thing here is that you write Arcade by your intent and not just by understanding the syntax itself, which usually takes much longer. A similar assistant is a code generation assistant for the Python API, and that's embedded into notebooks. Notebooks are a powerful way of doing data science and your automation workflows, but sometimes being able to use the latest version of the Python API can be a challenge, or just being able to understand code that someone else has written, or code that you want to generate, you know what it needs to do, but you don't know how to do it. All that is possible, and instead of me talking more, maybe we'll take a look at a demo by Lingtao. Over to you, Lingtao.
Thanks, Jay. The Notebooks Assistant. The Notebooks Assistant can explain, troubleshoot, and generate Python code for you. Let's take a look at how these three skills work in action. This cell here has a lot going on. Instead of reading it line by line, I'll have the assistant walk me through it. In the prompt, I just say, explain this code, and I pass in the cell's content. Since this cell does a lot, I want a clean breakdown of each step, so I can verify intent before I run anything. I'm expecting a plain language summary, what it loads, how it filters, and what the output is. All right, there we go. We've got a response. So the response is nice and clear. The cell loads the recent earthquakes, converts and filters the data, cleans and categorizes the magnitudes, and then aggregates the results. With that, I can run the cell with confidence. And here we got the aggregated earthquake table as expected. Next, I have a cell that adds the recent earthquake layer to a map. But when I ran it, I got an attribute error. I could dig through documentation and forum posts. But today, let's have the assistant fix it. I ask, why does this code fail with attribute error? And I attach the code snippet. Behind the scenes, the assistant checks the latest version of the ArcGIS API for Python. It understands what's current and what's been deprecated. For this particular snippet, I expect it to spot the older syntax and show me the modern one. And there it is. It points out the outdated method and provides the correct code. I'll drop that into the notebook and run it. Great. Now the layer loads on the map. Next, I want to visualize time trends over time using the aggregated earthquake table. So I asked the assistant to write code to create the time series plot. I also provide the code that creates the table, so the assistant knows the exact column names and data types to use when generating the plotting code. Now the assistant uses its general knowledge in Python, data science, and spatial analysis. It usually gives clean plotting code, including labels, legend, and good date formatting. And there it is. We've got some code back. I'll insert it into the notebook and run it. And there it is, a clean time series plot. I could keep going from here. Density analysis, buffers, or other GIS workflows. The assistant can help scaffold any of that. But to wrap up for now, I'll ask for a summary of the whole notebook. So I prompt, what does this notebook do, and what outputs does it produce? Well, that generates, here's a quick recap of what we saw. The assistant helped me understand unfamiliar code, fixed my code, and created analysis visuals. And now we're waiting for the summary, which is going to be something I can hand to a teammate or drop into the documentation of my notebook. All right, there it is. So to summarize, that's how the Notebook's assistant can help you work faster and move with more confidence. So you can focus on the analysis, not the syntax. Back to you, Jay.
Thank you, Lingtao. As you can see, there's lots of powerful capabilities in there. It's in beta, so check it out. Thank you. Next, we're going to look at how ArcGIS has become agentic. You can think of it as GIS itself is going agentic in many ways. And it's going to expand the reach and impact. There are two key ways that you can see agentic GIS emerge. The first one is you can think of as AI first or natural language first kinds of applications, a few examples that you see here on the left. Think of them as agentic mapping applications. And the other half is other agentic systems, other enterprise AI systems that can have conversations or that can run autonomously, calling into agents within ArcGIS. It also goes two ways, ArcGIS calling into external agents. All of this is possible through agent orchestration, both within ArcGIS and external to ArcGIS. So it's really an enterprise-wide intelligent transformation. To empower you as developers, specifically JavaScript developers who use the JavaScript Maps SDK, we are introducing AI components. This was introduced a couple of weeks ago. These are components for building such agentic mapping applications. This is what it has within it. It has a client-side multi-agent architecture, which really provides you a chat interface, the natural language first interface, to both navigate and explore the data in your web applications that relate to your web maps. They come in as web components, and they also have ready-to-use agents like navigation, data exploration, and the help agent itself. In addition to what you have within the JavaScript API, you can also call externally through MCP as a protocol, for example, and you can have these agentic workflows. It's available in beta now, and we'll have technical sessions that cover that. One example of such an application is the Data Explorer that we are building at Esri. And this is a natural language experience for map exploration, to do simple analysis, to find the data that you're looking for. These are powered by GeoSpatial agents, and it'll be available as an instant app template later this year. It's really about lowering the barrier of entry while using your authoritative GIS. And as we expand this, what we are really expanding is the IT platform for enterprise AI. It's really about bringing these agentic systems together in an open and interoperable manner. And it's providing geospatial knowledge, tools, and agents, not just for ourselves within ArcGIS, but also external systems. And these external systems can call into ArcGIS using a protocol called MCP. So if you go from right to left, what you see is your enterprise GIS system that has maps, services, and geoprocessing tools. These are exposed through this protocol called MCP, through an MCP server, no different from the REST services that we expose for our geospatial services today. It's a standard protocol that MCP clients can call into, and these clients are really representative of applications that you see out there that you might use every day within your enterprise. So you ask it a question, and it reasons out that this is a geospatial question and defers it to your GIS. Again, it's probably best demonstrated to see the impact of this capability, so I'd like to invite Mark to show us how it's done. Mark, over to you.
Thank you, Jay. Customizing agents with geospatial functionality can prove challenging, often requiring additional code or platform-specific tooling for each agent. When managing a large catalog of agents, this approach is not scalable. But with Model Context Protocol, or MCP, they instead can be empowered with curated data and tooling by pointing to a server as opposed to writing more code. Today, I will demonstrate how an agent for a city planning team can be empowered with GIS in a few button clicks using the ArcGIS MCP Server for Enterprise. I will first show how a GIS manager for that team can create and publish the agent from within Copilot Studio. Then I will show how a member of that team can use the deployed agent for their work from within the Copilot desktop app. Let's create the agent. In Copilot Studio, the manager can provide the agent with a name, a brief description, and a backing LLM. They also can provide instructions and prompting to better tailor the agent for the team. Note that while web search functionality has been enabled, that alone does not provide any specific GIS capabilities. It also does not provide access to the team's published content and data. To rectify this, the manager can connect the agent to the MCP server deployed to the team's enterprise. To do this, they can go to the Tools configuration pane add an MCP Server URL as a connection, and enable it. Upon doing so, the agent has access to the server's tools, each of which has a name, a description, and a schema that tells the agent when and how to best use the tool. Note that some of these provide out-of-the-box GIS, like geocoding and routing, while others provide access to the team's content for agentic workflows. With the availability of these tools, the manager can then publish the agent to the team's Copilot platform. Let's now see how a city planner can use that deployed agent from within Copilot. As a city planner, one of my tasks could be research into walkable corridors, the use of a network of roadways to prioritize pedestrian activity and safety. For today's research, I'm interested in schools as network anchor points within those corridors, as well as their proximity to various points of cultural importance. I can begin by going to the agent and asking it about the feasibility of walking from a particular high school, manual arts, to a nearby natural history museum. Without MCP, the agent would have to rely on its training data or web search functionality in order to answer the question. It may not be able to answer from those alone, or it may only be able to provide a conceptual answer that's not grounded in data. But with MCP, it has access to trusted GIS tooling. In this case, it recognized that it needed to geocode the start and end locations of the route using the Find Address Candidates tool. Then, using the resulting coordinates, it then invoked the Solve Route tool with the appropriate travel mode. In this case, the route takes about 15 minutes to go 3/4 of a mile, and the agent is able to provide step-by-step directions. Now, as a city planner, that's a good start, but I'm interested in seeing all the schools that could form a walkable corridor with this museum. That requires location data of schools in the nearby area. Because this agent has access to my enterprise content via MCP, I can ask it to search my portal for an authoritative NCES public schools layer and query it to find all schools within a mile of the museum. The agent can intelligently figure out which tools to invoke and the sequence by which to invoke them. In this case, it found the appropriate layer, the NCES Public Schools layer, and then used that layer along with the coordinates of the museum to perform a query. In this case, it's found about 17 schools within a mile, and it's been able to provide their names and addresses. With MCP, organizations can have confidence that their agents deployed across multiple platforms can be empowered with scalable and trusted GIS. Thank you. Back to you, Jay.
Thank you, Mark. What you saw was very powerful. And I want to summarize that GIS has all been about transforming your data into action, going up the value chain, like you see here, making decisions and actions upon them. All that AI is doing is accelerating this even more and doing it at scale. So this is the why behind the GeoSpatial AI platform itself. And in doing so, you're using MCP, GeoAI, AI assistants, and AI agents. It's amplifying every step in this pyramid as you go up this journey to act. And in this geospatial AI journey, what we've seen today is AI use right from data preparedness, getting your data AI ready, through building agentic systems, to connecting ArcGIS to other agentic systems, and making this all work in an enterprise AI IT platform manner. This is what happens when you build on your GIS investments that you trust already. Here you have AI that amplifies that impact. So with that, I'd like to encourage you to get started today. And thank you very much.